Venkat Anantkumar. I'm here to present my final project on finding the closest pair of points using the brute force and divided conquer algorithms. So the problem definition is concise and clear. Like we have points on a 2D plane. We need to find the closest pair of points in between them. So here we are going to implement two different algorithms. One is a brute force and the other one is a divide and conquer algorithm. Like I'm going to explain a brief about brute force algorithm and divide. Brute force algorithm is a simple algorithm which is repeatedly used, which is easy to use, easy to implement and use. And divide and conquer algorithm is an algorithm which has lesser running time. We're going to see them in the future. So the what is the I'm going to explain the problem. Like closest pair of points is a point. We have n points in a plane, and we want to find out the closest 2 points which has a minimum distance between them. This is the main problem of the problem. So here I'm going to use Java to implement the code, and we are going to implement this using Java programming language, and we are going to find out the empirical runtime and the predictor runtime, and we are going to plot the graphs for the both of them for the both codes. So here we have the pseudo code for the brute force algorithm, which I have taken reference from the lecture notes, and this is the closest pair of using divide and conquer. It has a recursive method, and this is the runtime algorithms. So this is the runtime for the brute force algorithm, which is big of n square, and this is for the runtime algorithm for the using case 2 of the Master's theorem. We can find out the runtime of the runtime. It is n log n, and here are the some tables which where we find out we perform the empirical RT, and we have predicted RT over here for the both the algorithms which we have performed operations. And these are the graphs which have been made, which are from the above tables. And first graph is the graphs of empirical RT of brute force and empirical RT of the divided conquer. Second one is the empirical RT of brute force and the predictor RT of brute force, and third one is empirical RT and predictor RT of divide and conquer algorithms. And this is the code we implement. We look into the code. So this is the code I have declared a class point, and declared a constructor, and I have created a method for the brute force algorithm, and find the closest pair. This is the distance method which I have used to find out the distance between the 2 points, and I have created a divided conquer method, and which it calls a recursive method of closest pair. And this is the pair. Here we find out by dividing the points into half. If it's more than 3, then these are the left half and the second half, and these goes again with the recursive approach, and we find out the closest pair distance by this. This is the closest pair of points method if we have a less than 3 points in the divided conquer method. And this is a random point generator we use to get the points. And this is the main method. In this main method I have declared the array, and this is for just printing the method points and I have used. So, and this is the start time before the brute force, and the end time I find the difference, and the start time before the divided conquer, and later on I use the end time after the divided conquer and find the difference. Here we can execute different number of times. We get different number of outputs. We can find the average by using 5 to 10 times of recursive approach. Here we can change the input to 1000 to 10,000. I have used 1000 to 10,000 and for the inputs, and found that. And I have used this plotter.com for plotting the graphs. It's a easy one, and this is the code. And I have found out the divided conquer is the most reliable method to find the closest pair of problems. Thank you.